Alright, so today we're going to be doing day 21 in Advent of Code. And today is going to be a quick one because I don't have that much time. So today's challenge, we get a sort of keypad that we need to press in a specific order to type something. So if we want to type whatever is in the input, 780A, we know that we always start at A, so our finger is pointing there, and then we want to somehow get to the 7, so we have to go left, up, 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 left. And then we only care about the most efficient path to get there. So of course we could sort of spin in circles and go all sorts of crazy ways to get to the 7, but we care about the most efficient path. And sure, there's several. We can go left a bunch of times, up, right, or up, left, or up, left this way, or just up, left. So there's a lot of ways to do this, but it just matters that we can get there without going to any invalid places, which would be this corner, which technically does not exist. And once we've done that, once we've said, okay, move left by saying, let's see, by saying left and then move up, move up, move up, move left, and then move A. A is like pushing the button. So we start at the A, but if we give it as a command A, so we're going to like presumably respond in a string like this, then we're saying move left, move right, and then press whatever you're on. But the problem is that we can't directly push this one. We have to use a robot to push the buttons. And how do we use the robot? Well, the robot begins by putting its finger on the A, and then it will move as we tell it to. So we can tell it, okay, move left, move down, right, up, and A to press. So here, our finger also starts at the A. So we have to say, okay, if we want to move left, up, 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 left, we have to go left here, down, left, press A so that we move the left once, and then now this finger here is pointing here. Then we have to do a bunch more moves from where we left off. So we were from here, we go right, we go up, and then we press A to press this. So we go from here to here, and it keeps going until we find the button that we want to press. And guess what? This is not safe either. It's radioactive or something. So what we need to do is take another robot to push these buttons, and then we can push the buttons that the robot has finally. So there's sort of two robots that we have to interact with, but the second robot's keypad or arrow keys we can press ourselves, and we start at the A. So if we want to move to this 7, then the sequence that we would have to push here, if we could push it ourselves, would be left, up, 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 left, A. So we start at the A, left, up, 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 A. That's how we would do it. But since we can't push this directly, we have to tell this robot to do it. So for this robot to just do the first move, which is left, so just to go to this 0, we would have to go from the A, so left, down, left, A. So here's the sequence that we have to do, left, down, left, A. And to just do this left first button, to be able to press it on this one with this robot's buttons, then we would have to also say left, down, left, A to be able to move left for this one. And then for each move, of course, we would have to do something else, and we have to continue where we left off. But once we've gotten the answer, so it's going to be a very long sequence of different arrows and different letters. So they've given us some examples. If we have 029A, this is what we get as the answer. And what they want us to answer in is not just this sequence of different arrows and A's. What they want us to answer in is the length of the shortest sequence. So let's say this is length 60, then we answer 60 multiplied by the numeric part of the code. So it means that since this is 029A, then we multiply by 29. So then we would get some number. So 68 was the length, and then 29 is a number. And then we multiply all of the different lines, points. So we multiply 68 and 29, and then 60 and 980, and so on and so forth. And then we add all of them together. So it's going to be 5 different answers added together that yield in the actual response that they want us to give. So if we go to the code, which I will briefly look over, what we do is that we have the input, which we get into lines. We iterate over every line, of course, to get the input. And what I've done is we've made a generate sequence function and a compute sequences function. And this helps us not only because we can cache the results, so we have cache here, and we can see that I'm using it in the compute sequence length. And this is useful because, okay, if we are going from 5 to 1, or from 5 to 3, or from A to 7, or from A to 8, and so on and so forth, we're going to do presumably the same moves a lot of times. So it's really useful if we can cache them so that we don't have to actually compute everything again. We just have the answer directly, and it makes the program a lot faster. But to make this even better, what we've done is over here I've calculated the sequences for the numeric pad and for the directional one. So if we see here, this is the numeric pad, and this is how we've defined it, just as an array, and then or as a list that has more lists inside. And then the directional one is the same, and it holds whatever buttons it actually has in the same order that they've shown it to us in. So we have the numerical keypad and the directional keypad, and what we've done is we compute the numerical sequences and the directional sequences. So if we look at this function over here, what we do is we get whatever keypad layout we needed, and then we pre-compute all of the sequences between the keys and the keypad using breadth first search. So we search, okay, is it possible to get from A until 7? And of course it's possible if we didn't request some weird number like 10 that doesn't exist, which should never happen. So it should always be possible to actually travel from a place to another. So it will find the correct answer, and we implemented it with a queue. And once we've gotten all of the sequences, which we get by appending it to this dictionary, what we do with them is that we pass it forwards every time that we iterate through the lines into generate sequences. So now that we've computed them, we can generate them as well. So what we do is that we go into, let's see, we create a list of the sequences, of course, and we include A as the starting key, and we add all of the paths to the current key pair, and we combine all of the sequences options into complete sequences. So that's what we do here. And basically what a sequence is okay, if we're traveling from 7 to 8, then we just say, okay, 7 to 8 is what we're traveling, and then the sequence would just be right. If we're traveling from 7 to 3, it would be a lot of different, so right, right, down, down. So if we were going from 7 to 3, it would be right, right, down, down, and then of course A, because we have to press it. So this one would also be A over here. So now that we've gotten the numeric inputs, we can iterate through every sequence, and we call compute sequence length, which we append to the lengths. So let's see if we can find it. There it is. And as we can see, we start with a depth of 2. So this is because we have 2 of these keypads that we're pressing, and one of those normal ones. And there is a base case that we have where depth is equal to 1. And we compute the sum of the lengths of the paths for each key pair in the sequence. And we include A again as the starting sequence. But if this does not happen, then we go to the recursive case, which recursively computes each subsequence. So we can see that it calls itself once again. And of course we add the shortest path that we found to the total length. Once we've returned this, we append it to the list, and then we find the minimum one, so with the shortest length. And once we found the shortest length, so whatever list length it was, if it's 10, we multiply it by whatever line we were at, and we remove the last element, which is A, so 780 times whatever answer we got for the first line, and then we get the total complexity, which is for one line, and then once we get it for all the lines, we get the answer. So if we run it, we get 246990, and if we look over here, we can see that that's correct. And now for part 2, it's quite simple because of the way that we implemented part 1. What they want us to do is, instead of just two directional keypads, we are going to have 25 of them. So it's a lot more. But if we look into this code, it's actually exactly the same. The only difference that we have is in this function, compute sequence length, and we have a depth of 25 instead of 2. If I put it back to 2, we can see that we're going to get the same answer, 246990. And if I put it to 25, we can see that we get a different answer. And we can just test really quick. If we remove cache, let's see what happens. So we saw that it ran basically instantly with cache, but if I remove cache, it will take basically forever. I still haven't managed to run this code without cache. So cache does really make a huge impact in here, because we're just traveling back and forth in between these few spaces. So just storing, okay, how to go from A to left without having to do a BFS every single time. It's so much more time efficient, and it's still running and it still doesn't work. So if I cancel it and we go back, we implement cache again and I run it, we can see it takes less than a second. So the answer was 306 something something, and that was the correct answer. And that was it. If you guys want to join the leaderboard, whoops, I did not mean to log out. I will leave a code in the description, and thank you for watching. Happy holidays and see you tomorrow.